Alright, so last time we looked at limits where the variable is approaching a finite number. So we had something like the limit as x approaches 0 of x squared. In this video, we're going to be looking at limits where the variable approaches infinity or negative infinity. So instead of 0, we're going to have really an undefined number, which is infinity. And I'm going to introduce an infinity rule for you. So last time we talked about this. The limit as x approaches 0 of 1 over x. And that this is really undefined, but a lot of times we consider this coming from the right. We say that this is equal to infinity from the right, or negative infinity from the left. But if we switch these, this is also valid. The limit as x approaches infinity of 1 over x is 0, because the number on the bottom, as you get to larger and larger numbers, causes the entire value to get smaller and smaller. So the limit as x approaches infinity of 1 over x is 0. Alright, so I have 5 problems for this video. We're just going to jump in and do them. So limit as x approaches infinity of 3x plus 3 divided by 5x minus 5. Alright, so as with any limit, the first thing we should do is try to plug it in and see what we get. In this case, if we plug in infinity on the top, we're going to get 3 times infinity plus 3, which is infinity. And 5x, or 5 times infinity minus 5, which is also infinity. Which we can't do, this is undefined. So the trick we're going to use here is we're actually going to multiply the top and the bottom by the leading coefficient, I think is what it's sometimes called, the leading variable. So in this case, the leading variable is x. And it's the same on the top and the bottom. So I'm going to multiply, let's see, multiply the top, that is dead, by 1 over x, and the bottom by 1 over x. And we can do this because this value that we're multiplying is equal to 1, so it's not changing the final answer. And now let's distribute. And we're going to get the limit as x approaches infinity of 3x over x plus 3 over x from distributing this term out into the numerator. And we're going to get 5x over x minus 5 over x when we do the same thing to the denominator. And by doing this, we can cancel the x's. And we can rewrite our original equation as 3 plus 3 over x divided by 5 minus 5 over x. And now we can actually just plug this in. Because in these pieces here, when we plug in infinity, we can use that same rule we used earlier, or we learned earlier, where the limit as 1 over, or anything on the numerator really, 1 over infinity is equal to 0. And we get our final answer of 3/5. All right. Alright, so the next one that I'm going to do is actually kind of simple. I probably should have done this one first because we already sort of did it, but I'll just do it quick anyway. The limit as x approaches infinity of negative 1000 divided by 3x plus 7. I wanted to show you this one just so you know to not get tripped up when there's very large numbers in the numerator. The answer is still the same. This could be negative 1000, this could be negative 10 to the 25th, or negative 25th. It could be an insanely large or small number, and the rule is still going to be the same because infinity is always larger than anything you can write. So what you could really do is split this up using the product rule. So the limit as x approaches infinity of negative 1000 times the limit as x approaches infinity of 1 over 3x plus 7. On the left-hand side, this is negative 1000 because there's no x there. And on the right-hand side, it's very similar to what we've done before. When we plug in infinity, we get 1 over infinity, which is 0. So the final result is 0. So yeah, pretty straightforward. Just don't get tripped up over weird numbers. All right, so the next one I have is using z. So the limit as z approaches infinity, and again, it doesn't matter what we call the function, we can use any letter we want, the rules are the same. The limit as z approaches infinity of z minus z cubed divided by 10 plus z squared plus 5 times z cubed. If we plug in z, we would get infinity minus infinity divided by infinity plus infinity, which would be undefined. It would be infinity over infinity, so we can't just plug it in. So we're actually going to use the leading term division again. So in this case, I will see the biggest term here is z cubed. So I'm going to multiply the top and the bottom by z cubed. Again, I can do this because this is 1. We're not actually changing the final value. I'll rewrite the equation. And we're going to get z over z cubed minus z cubed over z cubed divided by 10 over z cubed plus z squared over z cubed plus 5 z cubed over z cubed. That's a lot of z's. And now we can cancel some things. So the limit as z approaches infinity of z over z cubed is 1 over z squared minus 1, because these cancel, divided by 10 over z cubed plus 1 over z plus 5. Those also cancel. And now I think we can just plug it in. Because we have a z squared in the bottom, a z on the bottom, and a z cubed. And this should be fairly obvious, but if you have x approach infinity of 1 over x, this equals 0. And this is the same if you square x, if you cube x. All this is doing is making it approach 0 faster. But this is all valid. And so when we plug in infinity, we get this is 0, this is 0, and this is 0. And all we have left is negative 1 over 5. And there we go. That was definitely a little bit more complicated problem than most. There's definitely room for mistakes here when you're trying to multiply out all of the 1 over z cubes. And it looks a little messy, but it ends up actually being a very nice method to solve a lot of limits. So this would probably be the second thing I try when solving complicated limits like this. Just try to get it to a form where you can cancel a lot of stuff. All right, we got 2 more problems. So we are going to do, actually I'll just do 1 more this time. It's getting a little late, so we'll keep the last one for some other time. So the limit as x approaches infinity, oh shoot, of sine squared of x divided by x squared plus 1. So this is a tricky one because if we plug in infinity on the top, sine will always oscillate between 1 and -1. And sine squared would oscillate between 0 and 1. So the top will never actually approach a single value. In some ways it would be undefined. But we might be okay since the bottom does not oscillate. Oh shoot. So I'm going to rewrite this into 2 pieces. The limit as x approaches infinity of sine squared of x times the limit as x approaches infinity of 1 over x squared plus 1. On the right hand side, we know that this is 0 because we have an x squared term in the denominator and nothing in the numerator, or only constants in the numerator. So the right hand side is 0. And the left hand side, as I said before, we know this will be between 0 and 1. And either of these values or anything in this range multiplied by 0 is going to end up being 0. So the final result is just 0. So whenever you have problems with some type of trigonometric function in them, a lot of times with limits, they will end up not really mattering